Hello everyone and welcome to Thiot Ingenierie. The first thing you see when you come to visit us is the reception hall, the symposium conference room for our meetings and training courses, the administrative building, and here there is another video conference room. This is our order reception, preparation and shipping hall. Now, let's go to our test equipment design office. Here in this open space, which as you can see is quite spacious, is where we design our test equipment, as for example, gas guns, detonation chambers, Hopkinson bars, acceleration generators, and auto-fretage machine. And here we have a meeting room. Now we are going to the assembly hall, where the test equipment are prepared to be shipped to our customers. Here we have Chronos, the acceleration generator that allows us to know if the material is resistant or not to a given acceleration. With this system, we can test sub-assemblies, electrical or mechanical mechanisms, munition parts up to 80,000 Gs of acceleration. The particularity of Chronos is that we can perform a test and then self-recover the tested specimen. We perform a controlled acceleration. We apply an acceleration signal to a mechanism and we see if it survives the acceleration or not. Jupiter or press allow us to reproduce blast phenomena in order to characterize materials with large symbols of up to 200 tons in 3 milliseconds. Vulcan, our double-stage gas gun, allows us to reach impact velocities up to 3 km per second with this chamber. We arrived to the test preparation area. Behind me is the metrology room, and here we prepare all the mechanical parts of the test. And here we find all the necessary tools to perform the test. On my left, you can see Titan. This gas gun is dedicated to low mass and high impact velocities of up to 1 km per second. Titan can be equipped with a vacuum chamber to enable us to characterize material subjected to impact. Third is a gas gun that allows us to test larger masses at lower impact velocities. With this system, we can reach impact speeds of up to 500 meters per second. For both, we can have different calibers from 60 to 700 millimeters. This large space is our casemate, and it is dedicated to test complete aeronautical structures. We can fire any type of projectile onto any kind of target, so long as it fits into a 350 mm barrel, such as bird strike on turbine blades or windscreens, hailstone impacts on aircraft domes. We can place the camera and all the necessary metrology whenever we want. And with adapted configuration, we can also perform ballistic impacts such as set .62 mm bullet simulation. And we are in the metrology and control area for the 4 test equipment that I've just introduced here in the first floor. This room is dedicated for our own 3D prints, if, for example, we need some tools or accessories. Now we are in our break room. Here we meet every time we need to take a coffee or just to talk to each other.
Yes, of course.
The research and development offices are right here on my right. In this room, we can find the Hopkinson bars, the test equipment to characterize material subjected to high strain rates or temperature conditions. This one is a traction system, and this one a compression system. Finally, I would like to introduce Hermes, the 2-stage light gas scan that allow us to perform all our hypervelocity tests for space applications. Hermes is also equipped with a vacuum impact chamber dedicated to metrology, such as high-speed cameras and X-rays if required. Thank you so much for following me during this visit. I hope you enjoy it.